Alright guys, welcome to this page of the notes, and again what we're doing here is we're working on finding inverse functions. We already took a look at the fact that finding an inverse relation is as simple as switching the x and y coordinates. Turns out finding the inverse function works the exact same way. We have to switch the domain and range values, but it's slightly trickier here because you're not given actual xy coordinates, you're just given the variables x and y. So we have those guys switch places to find our inverse function. Let's go ahead and jump right into it. We've already taken a look at one of these, so again, we'll just follow those 4 simple steps to find the inverse function. This is the function I was given, f of x is equal to x minus 3 over 5. Again, I need to put that, I have been asked to graph it, so I'm going to go ahead and drop that, put that into slope-intercept form by just simply splitting those guys up, which means that I have 1/5 x minus 3/5. All right, so that is the function that I've been given, f of x, and it's in slope-intercept form. F of x is y, equals mx plus b. My b just happens to be a negative number. Anyway, the point is it's in slope-intercept form, so I can easily graph that. Y-intercept, and there's my slope. But I need to find the inverse function, so remember the way it works. Step 1 was to replace f of x with a y. So let's do that. Y equals x minus 3 over 5. Right, so I've replaced my f of x with a y. That was step 1. Step number 2 was to switch the x and y variable, right? We need to switch the domain and range values. So step 2 says x is equal to y minus 3 over 5, right? Switch the domain and range value. Step number 3 said solve for y. If I'm going to write a function, it needs to be y equals. So I got to get that y by itself, which is real simple to do. Multiply by 5 and add 3. So y is equal to 5x plus 3. And then step number 4, this is an inverse function. How do you let me know, or how do I tell you that this is an inverse function? Well, the original function was f of x, so the inverse will be f to the negative first power x. F to the negative first of x is equal to 5x plus 3. All right, so this is my inverse function right there. I have now found my inverse function, the original function I was given, and I ask you to graph both of them. So let's go ahead and do that. I'll do the inverse function in red. I'll do the original function in green. Let's go ahead and do the original function first. 3/5. Graphing fractions is a little bit tricky, so we'll go ahead and graph the decimal instead. 3/5 here, hang on a second, let me grab a calculator real quick and find out where I gotta go through. Let's see, 3/5 is gonna be 0.6, so right around 0.5 is close. I mean, these boxes are really kind of tiny, so if you go 0.5, you're good. It's a negative 0.5, so I'm gonna be right about there, close enough. And then my slope is 1/5, so that's up 1 and over 5. Up 1, and then do it again, up 1. I could go down 1 and back 5. Down 1 and back 5. Again, connect those dots with a line. Make sure you extend that line all the way through the coordinate plane and put an arrow on either side so that I know you know that line just keeps going. And that is my original function, f of x. Now, to graph the inverse function, this one's a lot easier. My y-intercept is 3, and my slope is 5. So I got to go to 3. And then my slope is 5, so that's up 5 and over 1. Or down 5 and back 1. Okay. Extend a line through those points. Make sure you extend the line all the way through the coordinate plane. Put arrows on either end so I know you know that line just keeps going. That's f inverse of x. And then I got a quick note down here just mentioning to you what I mentioned to you on the previous page. A quick way to check is to go ahead and graph the identity function, and your inverse function should be mirror images across that line. That's what I explained to you right here. We talked about it in the previous problem. Let's go ahead and use that check. Let's check to make sure I did this right, or at least visual check to see if it looks good. I graph that identity function, y equals x. Again, I'll put it in there as a dotted line because it's not actually part of the problem. I'm just using this as kind of a reference to see how it went. All right, so there's that line y equals x, the identity function, and it looks good to me. Those lines certainly do look like they're mirror images across that identity function. So I feel real good about what I've got here, both my function and my inverse function. All right, guys, at this point, you should be comfortable with finding the inverse relation, switching the xy coordinates, and finding the inverse function by switching the domain and range values, and then, of course, using the proper notation to call these inverse functions by the correct name. What we'll do on the next page of the notes is take a look at how you determine if two functions are inverses. So in this case, instead of me giving you a function and asking you to find the inverse, I'm going to give you two functions and ask you if they are inverses. So head on over to the next page of the notes, and I'll meet you guys there.